To everyone who likes to complain about how slow React Native is, I have some terrible news for you. React Native just got way faster, and the way they did it is really, really cool. The new architecture is finally here. I've talked about it a bit before, but it's time to dive in because not only is it here, it's here as the default for everyone installing React Native today. If you're on the latest version, you can now use the new architecture, and you almost certainly will be in the next couple weeks. So, what does this mean? What is it doing? Why should you care? Great questions, but first, quick word from today's sponsor. If you're a React Native dev, statistically speaking, you're probably a Firebase user, and that hurts me. I'm here to beg with you, to plead with you. Please stop using Firebase. There are so many great alternatives, one of which is today's sponsor, Convex. Convex is the only decision you need to make for your backend, and I understand mobile devs want to focus on building great applications, not all of the complexity of building infrastructure, and Convex is here to solve that for you. You define a query with literally 5 lines of code, and then all you have to do to use it is call the hook. Use query, the API call that you defined, and now you have the data. It's that easy. And you're not giving up all the ownership like you do with a model like Firebase, where you're hitting their backend and their APIs that you have no control over. The logic, the code, the important part lives in your directory. And this isn't some crazy Next.js backend deployed thing I'm showing you here. This is from the Expo example. You make an Expo app, you install Convex, and now you can do the backend side, the auth side, file uploading, and all of the things that you would use something like Firebase for in a much more React-y and TypeScript-y way. And by the way, they do all the live sync stuff too. No longer do you have to deal with crazy event management. You just query some data and it will automatically update when the data's been changed. It's never been easier to build a full stack application. Stop being scared of servers. Stop being afraid of backend. Stop worrying about all those decisions when you can just use Convex. Anyways, the new architecture is finally here. React Native 0.76, 1.0 when? Where are we getting our 1.0? How long has it been? I had to. I know. We're saving 1.0 for 2100. Thanks for the free dunk. Anyways, as we were saying, React Native is still not 1.0. They're holding that as a real high bar. But at the very least, we get the new architecture now. And that's going to introduce some really fun things, including full support for modern React features like suspense, transitions, automatic batching, as well as use layout effect. The new architecture also includes new native modules as well as native components. And these allow you to write type-safe code with direct access to native interfaces without a bridge. This is a really, really big deal. I emphasize this whenever I talk about React Native, but I really want to emphasize this here. React Native is native, and I think people often miss that. You're not running a web view inside of your mobile app. Your JavaScript code is telling the native platform what to render. A button in React Native is a native button. A tab bar in React Native is using the tab bar that's built into the operating system that your platform has. And if it doesn't, then one will be built that behaves roughly how you would expect on that platform. React Native is a way of telling the native platform, using its native primitives, what it should natively do. The issue here is that a bridge was created to bind between those two things. And that bridge got us really far, and it was honestly pretty good. But the thing that is new here is that you no longer need a bridge to call those things from the native world. Calling the native C or C++ code, calling the native Kotlin or whatever's going on in Android world, all of that no longer requires that you use this bridge to copy values and pass messages back and forth. You can even basically share memory between the two sides. It's really powerful what this enables. And when you combine this with the future with something like static Ermes, where your JS code is being compiled to assembly, the way this all comes together is that you make really fast apps using the primitives that we're used to building simple web apps. And that's a really cool, really promising future. I also think use layout effect finally working is huge. If you're not familiar with the difference between use effect and use layout effect runs after the render. So if you were to, I'll just do a quick demo of this. I want to make sure we understand the difference between these effect types in order to make it clear why layout effect is so cool to now have in React Native. I made a quick demo to show it. I have this console log when the ref gets mounted on the page. So when this div gets put on the page, the ref gets bound and it will call this log. So we'll see when it loads, we get D, happens multiple times, React doing things multiple times in dev. It is what it is. Ignore that part. Let's say I put a log here. We have C render, and then we have D, which is the ref binding. Hopefully we all know the order that's going to happen. Obviously, the render code is going to run in the JavaScript before the element appears in the browser. What about this use effect, though? Where will that run? It comes first, so it should happen before, because it runs on mount, right? That's what happens when you do an empty array use effect. Not quite. It runs on mount, but it runs on mount after the first render. So you have the render, Then you have the ref binding. Then you have use effect, which is cool because if you bind a ref in this stage, you'd have access to it in the use effect. So if I actually bound this ref to a use ref call, I could access the data that's in there. So what does use layout effect do? We have A, B, C, D. A is use effect, B is layout effect, C is render, and D is ref. What order do you expect this to be in? Where does use layout effect go? This was even unintuitive for me a little bit because I just didn't know how the ref binding would work, but I think this will be useful to know. When I run this again, we get C, then D, then B, then A. So what is the actual difference between use layout effect and use effect? It seems like use effect comes first. Well, there's a specific step in the rendering process that use layout effect lets you get in front of, which is when the layout actually becomes part of the page the user sees. So when the order of events here is that the component runs, it calls all the logs, it creates this, it puts it in the DOM, but it doesn't let the browser paint it just yet. So the content is there, the browser's ready to show it to you, but it hasn't yet. In order for it to show it, use layout effect has to run first. I'll show you what I mean quick. I added a ref to the title, and here I set the color to red and the size to be much bigger. I also threw a transition on it so that you'll see that it was actually different before. So if we load this page quick, you'll see the hello world comes in the corner in white, and then it expands and turns red. The reason that it does that is there is a flash, there is a moment where the browser sees that content in that way before the use effect runs and changes it. If I just take this code and move it down here to the use layout effect, now it will run before the user gets to see the result, which means any transitions, those types of things don't happen because the wrong state is never shown. So I go back here and refresh again. It just starts in the right state. That's the key. Hopefully this helps you understand why this is cool. But how the hell do you get that working on React Native? Because React Native doesn't have this concept of a DOM that knows how big things will be, so you don't get access to the same stuff. I'm very curious to see how they handled that in here. Oh God. This is how we did it before. I was mostly able to avoid these things when I was working React Native, but seeing how you were supposed to do it is terrifying. You had an onLayout function. You would bind the ref separately, and then onLayout is when you would trigger things, like measure the size of the thing in the window and do things there. Use layout effect gives you that synchronous access that we all so crave and desire. Now, a use layout effect lets you get the bounding client recs and use it for whatever you want to do to make sure that your tooltip is rendered in the right place in the UI before the user sees it. In the old architecture, layout was read synchronously in onLayout, which caused the position of the tooltip to be delayed. Oh God, yeah, that sucks. So the tooltip needs to know what room is available on the page. It tries to go on top, but if there isn't room on top, it goes on bottom instead. The old way, this would move after because it doesn't trigger the recalculation until after. Now, it blocks before it shows it to the user, so both can move together. That's really cool to see. Good demo here too. Anyways, let's go through all of the fun things and what the new architecture actually is. This is the ground-up rewrite of React Native that they've been working on since 2018, and we've taken extra care to make sure that the new architecture is a gradual migration for most apps. In 2021, we created the new architecture working group to collaborate with the community on ensuring a smooth upgrade experience for the entire React ecosystem. Most apps will be able to adopt React Native 0.76 with the same level of effort as any other release. To be fair, upgrading in React Native is never fun, so the same level of effort isn't fun. But it's doable, which is nice. I've succeeded before, although most of my success is starting a new React Native project, moving all the code over, and it just works. It is what it is. Thankfully, the most popular React Native libraries are already supporting the new architecture, and it also includes an automatic interoperability layer, which enables backwards compatibility with libraries that are still targeting the old architecture. Over the past several years of dev, our team has publicly shared our vision for this new architecture. If you missed any of the talks, check them out below. Covered these here and there, all really good stuff. Check it out if you haven't. But I'll do my best to give you the overview that you need to hear. The new architecture is a complete rewrite of the major systems that underpin React Native, including how components are rendered, how JS abstractions communicate with the native abstractions, and how work is scheduled across those different threads. Although most users should not have to think about how these new systems work, the change does bring improvements and new capabilities. In the old architecture, React Native communicated with the native platform using an asynchronous bridge. And this is the key I was talking about before. Yes, React Native told the native code what to do, what to include, what to put where, but you had to block and wait on each side. It wasn't synchronous. It wasn't immediate. You had to send a message and then wait for a response. To render a component or call a native function, React Native needed to serialize and enqueue native function calls with that bridge that they had built, which would be processed asynchronously. The benefit of this architecture is that the main thread was never blocked for rendering updates or handling native module function calls, since all that work was done on a background thread. And again, that's the intuitive way to do things with JavaScript. Since the main thread isn't blocked, it can keep doing things while in the background, the native layer is doing its rendering. But this comes with its own issues as well. Specifically, that users are expecting immediate feedback to interactions and that those should feel like a native app. Remember this video I just did, controlled inputs, where I showed how bad controlled inputs were in React Native, where if you type quickly when you're using a controlled input, it lags like that. And if you're not familiar with what the term means, it means on change, you set it in state, and then whatever the value ends up being, you show here. This was asynchronous, which means every key press had to send a message to the JavaScript code. The message had to be processed. Then it would have to send another message to the native code telling it, hey, update this value to be this other letter. And that all had to happen in the time between key presses in order to prevent tearing and all the weirdness that could exist. The new architecture doesn't magically make this problem go away, but it will make it a lot easier to avoid these types of problems. And honestly, I would bet if you just flip this over to new architecture, it will be significantly less bad than it is in the demo here. It is what it is. I still don't think they should be recommending this pattern in React Native ever, but since the new bridge isn't a bridge, it's a native binding between the two, it should handle this much better. As they say here, users expect immediate feedback, and that means that some updates need to render synchronously in response to the user input, potentially interrupting an in-progress render. Since the old architecture was only asynchronous, we needed to rewrite it to allow for both asynchronous and synchronous updates. Additionally, in the old architecture, serializing function calls over the bridge quickly became a bottleneck, especially for frequent updates or large objects. Again, what I'm saying, when you're typing really fast, not great when you have to serialize each of those changes each direction. This made it hard for apps to achieve 60 plus FPS reliably. There were also synchronization issues. When the JS and native layers got out of sync, it was impossible to reconcile them synchronously, resulting in bugs like lists showing frames of empty space and visual UI jumps due to intermediate states rendering. One more call out here, 60 FPS is, I would say, table stakes nowadays. If you drop frames on mobile, it makes your app feel a bit slower, sure. But if you drop frames in VR or AR, especially frames that are interpreting like the environment you're in or the space in front of you, it can make you very motion sick. It can actually make you ill. If I'm in a VR headset and I have a React Native app right there and I move my head and it doesn't stay here when I move, it like follows a little, then goes back and like judders. That tearing between the movement I'm experiencing and the thing that I am seeing will trigger sickness. It is a huge issue. And with things like VR and AR, having a really stable frame rate that meets the expectations that our vision and most importantly, our peripheral vision have is super, super important. And now that they're using React Native so heavily inside of Meta, inside of all of the stuff they're doing in VR, they care more than ever about performance. Finally, since the old architecture kept a single copy of the UI using the native hierarchy and it would mutate that copy in place, layout code could only be computed on a single thread. So all of the computation for the layout had to happen one thread because there was only one instance that was being mutated and copied. As an immutable boy, someone who loves to not change values but make new values, that's terrifying. I never thought of it that way, but that's really scary and makes a lot of sense why complex React Native apps were inherently slower because you couldn't parallelize the work at all when it came to the rendering. And as I call out here, this made it impossible to process urgent updates like user inputs, and layout could not be read synchronously, such as reading in a layout effect to update the position of a tooltip. Huge deal, because if you have a key press and you want to interrupt the other things going on, you can't because there's only one thread doing that update in the first place. Really good changes. It's amazing React Native was this good without all of these things. I'm so excited to see where it ends up now. Poor Flutter devs. Also of note, because this was single-threaded, it meant they couldn't support all the fun new concurrent stuff happening in React, with all the transition work, all the suspense work, use layout effect. These things that require concurrency weren't possible before, and now they are trivial. Mind you, implementing the new architecture, not trivial at all, but it enables all of these things to be built the React way. The new module system is also really cool, as it allows for React Native's renderer to have synchronous access to the native layer directly, which allows it to handle events, schedule updates, and read layouts, both async and sync. The new native modules are also lazily loaded by default, which give apps a significant performance gain. That's really cool too, that you don't have to wait for all the native modules to spin up and tell you that they're ready before you can start getting the UI ready. Really nice change. The new renderer can also handle multiple in-progress trees across multiple threads, which allows React to process multiple concurrent update priorities, either on the main thread or a background thread. Update priorities means that different things you're doing in the UI have a different priority. When I am typing, I need to make sure that the text I'm typing is visible instantaneously. That's more important than if I have, when I type, it auto-fills a search underneath it. If I press another key, I don't care what's going on with that search load and the spinning underneath it. All I care about is seeing that result of the key I just pressed. There was no concept of this update matters more than this update before because there's only one thread. There can only be one update. You couldn't interrupt. Now you can. Really nice. And it means things, again, like that jank with the controlled input are much, much easier to solve. It also supports reading layouts from multiple threads synchronously or asynchronously in order to support more responsive UIs without jank. The new event loop can process tasks on the JavaScript thread in a well-defined order. This allows React to interrupt the rendering to process events that are urgent enough that they should take priority, as I said before, like when you're typing, and that should take priority over any lower priority UI transitions. It's also cool that they support all the fun web spec stuff like microtasks, mutation observers, and intersection observers, because these are not easy to implement. Having these working in native is really, really powerful and quite exciting. And of course, removing the bridge allows for faster startup between the JS and native runtime now that you're not building this huge thing between them. So the cost of switching work between native and JS is now minimized. It also allows for better error. Oh boy, I hadn't even thought of that part. The debugging and error reporting side here is going to be a lot better. Oh man, that's, if anything, is the problem with React Native. It's the quality of the debugging and error management experience. It was not fun. It was one of the few things I actually was impressed with Flutter. This makes it a lot easier to catch up in the React Native world. Exciting. Why would we ever... So they say the new architectures are now ready to be used in production. It's 0.76. You're using things that aren't a major version in production. It's not even 1.0 yet. Is Facebook really shipping tech that isn't 1.0? I thought you were a real company. What the hell? Joking, obviously. It's already used at scale in Meta in the Facebook app and in other products, like all of their VR stuff. We successfully use React Native in the new architecture in the Facebook and Instagram app that they developed for their Quest devices. Yeah, the Quest version of Instagram and Facebook is entirely built with this React Native and new architecture stuff. I've been told by many people I need to try them, specifically the Instagram app in Quest, because it's really good. I have not had a moment to, because I've been far too busy, but I do actually plan to do that very soon. Our partners have also been using the new architecture in production for months now. Have a look at the successful stories that exist with companies like Expensify and Kraken, and also Blue Sky's new release is using the new architecture too. New native modules. The native module system is a major rewrite of how JS and the native platform communicate. It's written entirely in C++, which unlocks many new capabilities. Fun fact about multiplat that a lot of people don't know. If you want to write native code that works on iOS and Android, the language you write that in is C++. If you don't know this about Twitch, the chat color of your name is fully customizable, as in you can pick any hex code that you want. There's an issue with this though. Twitch has dark mode and light mode. That means if you pick a color that isn't compatible in the contrast sense with the color scheme a user's using, like if I pick straight white or something that's white enough that in light mode it doesn't have enough contrast, it sucks. So Twitch added a fun feature here, readable colors. And if you turn this on and off, you might not see much of a difference here. But if somebody had a name with a color that didn't have enough contrast, this would change the color in order to make sure it contrasts the right amount. Something that was really important to the team working on this is that chat colors looked the same on every platform. So the iOS version, the Android version, and the web version, if all three were in dark mode, your username should be the exact same color in all three. Which means that the code written to make the colors readable, to do that hex code transformation, is in C++, because that is the best language to make something that is truly multi-plat and doesn't have massive potential performance issues depending on how that platform handles the performance for it. So all of the code that handles the color hex code transformations for Twitch, for chat, is in C++. There we go. Cool. See that? Since I'm not a mod, see how unreadable that is by default? If I switch the switch on, it becomes readable. The code that does that, even in the browser version, is C++ and WASM, because we wanted to be sure the math would be identical on every platform. So yet again, we have a wonderful example of using C++ for UIs, which is one of my favorite things. So as I was saying here, if you want to have fast code that runs exactly the same on all platforms, and iOS and Android are your concerns, C++ is probably your solution. Thank you, chatters, for helping me with that. Anyways, By writing this binding layer in C++, they've unlocked a lot of fun things, from synchronous access to and from the native runtime, so again, you can just call in and out without having to block and wait for I/O. Type safety between the JS and native code, also very fun because they're the same environment, so to speak now. Code sharing across platforms, because again, C++, code share is now an option. Previously, the bridge was written in different things for the different platforms. Now there's one bridge. It's almost like you can think of this almost like the JVM if it was more native and built around JavaScript and for native applications. It's kind of nuts. And obviously the lazy module loading I mentioned before, it's now in and it's the default. It's really cool. In the new native module system, JS and the native layer can now synchronously communicate with each other through the JS interface, the JSI. And that means that they no longer need to use an async bridge. So your custom native modules can now synchronously call a function, return a value, and pass that value back to another native module. Previously, if you called native modules, you'd have to have like a callback when the value was returned. Yeah, sync callbacks from native modules. So you'd have to use this get value to get your callback, and that would have to be async, and then do something here. And value cannot reference a native object, so it has to be a clone of it. So if you get something from the native layer, it has to be serialized. It's almost like the native layer is backend and your React code was front end, but the front end code is telling the backend code what UI should exist. Fun stuff. Now, you can just say value equals native module.get value, and that can be a reference to something native. Huge, huge change. Yeah, this is an async callback, not sync callback. Thanks for catching that, Ricky. A lot of people tend to catch typos in these things. No worries at all. I'm happy you guys got this out. Anyways, you can now finally leverage the full power of the C++ native implementation while still accessing it from JS and TS APIs. So cool. Remember earlier when I was talking about static error maze? Starting to see how powerful that might end up being? There is some fun stuff happening here. The new module system supports modules that are written in C++, so you can write your module once, and it will work across all platforms, including Android, iOS, Windows, and Mac. What about Xbox and PlayStation, my favorite React Native platforms? Implementing modules in C++ allows for more fine-grained memory management as well as performance optimizations. Additionally, with some code gen, your modules can define a strongly typed contract between the JS layer and the native layer. From our experience, cross-boundary type errors are one of the most common sources of crashes in cross-platform apps. Yep, not knowing the type of the thing you're accessing tends to be the problem. This is also the case with the bugs between backends and frontends. Most of them are because the frontend expects something the backend doesn't, or the backend expects something the frontend doesn't. If you have type safety between these layers, life gets much better. And as I said before, the native layer is kind of a backend, so to speak. Having safety between those layers is really powerful. I am curious about this code gen. So code gen is a big new thing in the modern React Native version where you can generate code when iOS and Android apps are being built. You can also manually call it. What does it actually do, though? It's tightly coupled with a React Native app. It lives inside the React Native NPM package, and it crawls the folders in your project, starting from a directory that you specify in the package JSON, looking for some specific JS files that contain the specification or specs for your custom modules, as well as components. Spec files are JS files written in a typed dialect. React Native currently supports Flow and TypeScript. So now the code gen will generate boilerplate code, and it uses the type definitions to make sure it's right on the other side. It uses the definitions on the native side to make sure the types match what is expected. It means your types and your native code are now much more in sync. Very nice. Modules are also now lazily loaded, as I've said a bunch of times now. Reduces startup times and keeps the complexity low. If you go to different views that have really heavy modules, those modules don't get loaded until then, and you can have your homepage on your app start immediately, even if other things in the app are slower. React Native MKV is a phenomenal library. It's a key value store that you can use in React Native that is really, really fast, like hilariously so. Yeah, and as of their v3, which requires the newest React Native and the newest architecture, it is now a pure C++ turbo module. That's why it is so fast. It is a C++ code base. That is really cool. Does that mean that the React Native ecosystem is going to have more truly native devs than like the Swift ecosystem? Because Swift is a bigger abstraction on the native behaviors than C++ is. That's kind of funny. Regardless, this is cool. The new architecture doesn't just make it faster, though. It also allows it to be fully type safe, which fixes a long-standing null pointer reference issue, because now they can enforce null safety, which they couldn't before because there was no safety on these other sides. Good stuff. They also completely rewrote the native renderer, the thing that actually puts the native elements on the native application layer. That means that updates can be rendered on different threads, as I mentioned before. They can be read synchronously across all different threads. And the renderer itself was written in C++ and now can be shared across platforms. The amount of platform-specific code that's probably killed by these changes is really cool to think about. especially now that React Native isn't just iOS and Android, it's supporting so many other things. It's a significant step towards their many platform vision. View flattening was an Android-only optimization in order to avoid deep layout trees, but the new renderer with the shared C++ core also brings that feature to iOS. This optimization is automatic and does not require setup. It comes for free with the shared renderer. Good stuff. The new renderer also is why the concurrent stuff works. We've talked about that already. What we haven't talked about is the libraries that support it, like Reanimated. If you're not familiar, Reanimated is a wonderful, wonderful library because it shows just how fucked we are in the web world. Because Reanimated makes it so easy to do good animations for things, including entry and exit animations, like proper enter and exit. See this? We'll never have this. Our beautiful JavaScript web world will never get a proper entering and exiting. Because when you remove the element from the browser, it's gone. You can't run animations on a thing that isn't there. So you have to abstract the removal of it in the React code. You can't just remove the div. You have to have the div in a state where it fades, and then after that is done, trigger the removal. And that multi-step thing is just the reality of building for the web. But since React Native is a different abstraction, they don't give a shit. They can just give you access to that rendering layer and define an exit function and define something that allows it to break out. Yes, the View Transitions API is a thing, but the View Transitions API is much more focused on navigation when the whole HTML works and more on how things move when they shift around, not on animating things being removed. It does allow for it, but I haven't seen anybody with a good demo of like a list where when I click X on an item in the to-do list, it goes away with a nice animation without having to do everything with some heavy JS layers. It's a huge thing. And when you're working React Native a lot and then you go to web for a bit, you end up missing Reanimated a ton. And now it's way faster. As they say, they have a new animation engine that works directly with the new renderer, which allows it to handle animations and manage layouts across different threads. The new renderer's design is what truly enables these features to be built without relying on numerous workarounds. Since it's implemented in C++ and shared across platforms, large portions of Reanimated can now be written once, reducing platform-specific issues, minimizing the codebase, and streamlining adoption for out-of-tree platforms. Huge stuff. And everyone's favorite, the event loop. There is finally a well-defined event loop in React Native. They're trying to get it as close to how web and HTML works as possible, and they're pretty damn close to it. This closes the gaps between the React DOM library, which if you're not familiar, React is the thing that you write your JSX in and build your virtual DOM, your tree of what's going on with. React DOM is how you then put that in the browser, how you have a div or an H1 or all of those. React Native is the renderer to do it on other platforms, why you have a view component instead of a div and all of those things. There was a pretty big gap between these and how they worked. That gap has been significantly close to this architecture. React Native is closer to React DOM than it's ever been, which helps deliver on the original promise of learn once, write anywhere. The event loop also brings some fun benefits like interrupting rendering, closer alignment with web, and a foundation for more browser features to be supported in React Native. Now we're getting into the fun, what I'm here for, the removal of the bridge. Old layer. We had the React renderer, the async bridge, the native renderer, and the RCT view. Ta-da! Now the React renderer triggers the native render directly and synchronously with the direct bindings to those C++ functions. Ta-da! This is a fun example. This is using a native timer so that you can trigger a timeout correctly using the native timer. Previously, to instantiate this, you would have had to do some weird importing, set timeouts on the global to define this, and then you could call it. But you had to interrupt startup of the app to do it. Now you just call runtime.global.setProperty, and it runs when it's ready to. You don't have to worry about it. Oh, JS crashes at startup is such a problem. It's so hard to debug if the app doesn't even open. This does make that a lot easier. And the new React Native dev tools will simplify debugging and support new dev tools. How new are these? That's a lot better already. It's all based on the Chrome dev tools. It lets you connect. What this does is you create a bridge from the native application, either on a real phone or in a simulator on your computer, and then you can connect that in the JS instance there to the Chrome dev tools. It's good stuff. Got the pro tip to look at this other blog post that brings much more info about the new dev tools up. We want the tooling you use to debug React across all platforms to be reliable, familiar, simple, and cohesive. The React Native dev tools deliver on these principles. They're browser-aligned developer tools that are deeply integrated with React Native. Finally, this is the thing I'm most hyped about so far, actually. I've wanted this so bad for so long. This is the biggest missing piece for this is the biggest missing piece for React Native, and it's like finally being fixed. Oh boy, finally. Yay. Fix the reconnections. It was so unstable. That's such a good change. Yay. The React Native dev tools are fundamentally a different experience from our previous debugging options, including being different from the experimental debugger experience that they first shipped in 0.73. It switches to a new backend debugging stack that they've rebuilt over the last year. That means compatibility with previous tooling has changed, and you should expect a much more reliable experience end to end. Finally, this should have been there long ago. I'm hyped. They have a whole section here about gradual migration. Really useful for all of you guys building real applications. I'm not one of those people. I would be building a new app with this, so I don't care. It's there if you want to read it. But here we have the new features. A lot of these are new React 18 features, so if you've kept up with that, you're probably kept up already. But if you haven't, quick overview. You have transitions that allow you to distinguish between urgent and non-urgent updates so that things like typing can be prioritized over switching UI states. I like the example here. They specifically call out that a user input should probably result in both urgent updates as well as non-urgent ones. Similar to React DOM, events like a press or a change are handled urgent and rendered immediately, and you can use start transition inside of one of those input events in order to tell React which updates are and aren't important. Imagine a slider that generates tiles depending on what the value is. You slide it left to right from 1 to whatever. You would want the number and the state of the UI, like when I drag it, you'd want the input to move immediately, but you wouldn't want the tiles being rendered to block me moving that thing left to right. So we call set count before the start transition. And that is telling React, hey, by the way, this is a priority. This isn't. So if I do another one of these soon after, throw away the work you were doing here, ignore it. The priority is here. So I can see why this release took so long. As people are saying here, this is the biggest launch of React Native since it originally came out. And Rick from the team agrees. Yeah, this is very nice to have inside of React Native. So here what you'll see is you get a loading state and you can move the bar around and show an old state here without the bar being blocked by it. Here it gets blocked. You have to render these things. So if you're sliding, you'll see the slider stop and go a bit further. Yeah, very nice. Very cool to have that finally. Also, automatic batching. Previously, you'd get this weird flowing in. Now with the automatic batching, the updates will come in chunks instead. So the UI updates won't be as weird and jarring. They get batched. Very nice. The count here doesn't update, but the slider position does, since the slider's uncontrolled. That's a detail I didn't notice here. Okay, I actually misread this entirely. Okay, yeah. So the difference here is actually more subtle than I thought. Notice that here, the number stops until the rest can render. And here, the number constantly goes up as you're sliding it around, because updating the number there is cheap. Rendering the tiles isn't necessarily. And that means there's going to be points where this shows a number that is different from the number of tiles actually being shown, because they are separating those behaviors. Really cool. I already discussed use layout effect, really useful for things like tooltips. Suspense, finally. I have so much content about suspense. I hope you guys are already familiar with that at this point, so I could skip that. We now have proper full suspense support in React Native. And finally, the how to upgrade section. As I mentioned before, I'm not upgrading. I'm starting from scratch. I have it here if you need it. So on a high-end device like a Pixel 4, the difference here is not that great. Also, Android being Android means there's a pretty large abstraction there. But if you compare that to iOS, you'll see a good size, bigger, nicer bump here. With 5,000 images, 33% faster. Pretty good. What I would like to see is more of the like perf on interactions and such. I'd imagine a lot of that, especially with like bad enough apps, could possibly be 5x plus better. But this also, more importantly, enables us to build in ways that we couldn't before. I have my clickbait. One of the screens is 5.3 times faster for the Kraken app because of the new React Native architecture. Huge. The automatic batching for things like this, oh, it's so good. This is actually a great example of an app that benefits a ton from it. Good shit. Thank you for this. That's all I got. I couldn't be more excited for React Native. I might even go start working on a new app. What about you? Are you going to try React Native in the future, or are you sticking with Flutter? Let me know. And until next time, peace nerds.